Okay, the second type of applications that you're going to see on here quite a bit, very common with quadratics, is, or I guess very common application that we can practice at this level of mathematics is quadratics, with like maxes and mins and other things related to that. So if we look at number 3, I'm going to read through the whole thing so we kind of know what we're looking for, and then we'll come back and use the function as needed. So while playing catch with his grandson, Stanley throws a fly ball as high as he can into the air. The height of the ball, h in feet above the ground, so h is height, is given by the function h of t is equal to negative 16t squared plus 64t plus 8, where t is the time in seconds, okay, that the ball is in the air. So let's just talk about this function really quick. Notice this function is a squared function, right? Well, that's awesome. We know it's going to make a parabola. The 16 is negative out front, so we know that he's going to launch that ball in the air and then eventually it'll come back down where his grandson can catch it, right? So we kind of can tell some things that are related to the function. We kind of know what it's going to look like. And it looks like as time passes, right, this is probably our like time passing, the height of the ball will change. So as time passes, it gets higher in the air and then it comes back down. So just kind of a context of what it would look like. Now, part A is going to ask us, what is the initial height of the ball at the time Stanley releases the ball? So this is initial height, okay? Then at what time will the ball reach its maximum height? So again, it's asking what time are we going to hit a maximum? Then it says, well, what is that maximum height? So the biggest thing with quadratics, when you see the word maximum, remember we practiced finding this, but the maximum is like related to the vertex, right? And if our vertex, so here's our point, every time we calculate a time, right, at what time does it hit a certain height, the y value represents that maximum height. So it's really important we understand, and I usually draw out the vertex just to look something like that. So here's like, anytime I want to find a time, that's my x value. Anytime I want to find a height, that's my output or my y value. So as I answer these questions, we're going to kind of relate to the inputs and outputs. So here it says, what is the initial height? Now, initial height means that no time has passed. So whenever you see initial, right, height, no time has passed, meaning that t is going to be equal to 0, right, when no time has passed. So essentially what we're saying is, well, let's find h of 0. If I have negative 16 times 0 squared, again, t is equal to 0, then we know that it looks like 0 squared times negative 16, that just goes to 0. 64 times 0 goes to 0, and it's really just 8. So it's that y-intercept, right, would be 8 feet in the air. So he's launching that with his arm, reaching up, releasing it at, I guess, where the ball is 8 feet above the ground. Then it asks us again at what time, so time means the x value of the maximum height, so the x value of the vertex. Now remember, if the function is in standard form, then to find the vertex, we did negative b over 2a. That was the x value of the vertex, so that can give me the time at which my maximum is going to occur. So again, I come over here and I say, okay, well, time for negative b over 2a. If I look at my b value, that there would be 64. So negative 64 over 2 times the a value, negative 16, is equal to negative 64 over negative 32. So 64 over 32 would be 2. Now again, that represents time. So what we're saying is that at 2 seconds, okay, or after 2 seconds, I should say at, we're going to actually reach the maximum height. So the ball is going to go up for 2 seconds before it starts to come down. What is the maximum height? Well, remember, to find the y value, once we knew the x value, we just plugged the 2 in. So at 2 seconds, right, when t is 2, we're saying what would this be? So we're putting 2 into our function. And if we evaluate that, 2 squared is 4 times negative 16 is negative 64. 64 times 2, 128. And that would leave us with 72. So what we're saying is the maximum height that the ball is going to reach is 72 feet before it then begins to fall down to be caught. Okay. Again, read through the entire problem so that you know what you're looking for. Anytime you see maximum or minimum, you're probably dealing with the vertex. You just need to understand which part of the vertex represents which outcome. Is this time? Is this height? Sometimes it will be distance and height. So we just need to make sure we understand which part we're looking for.